Welcome to another data science deep dive on our technical track. In the following presentation, we have Dr. June Andrews, former head of data science at Stitch Fix. A central component of Stitch Fix's ability to match clients with clothing they will love is the data-driven curation of their expensive inventory. Knowing ahead of time how well their inventory will perform not only reduces costs associated with missing the mark on what clients will love, it also provides great insights into the inventory that will be the most successful with a growing client base and existing sales channels. Here, June presents the history, lessons learned, adjustments that they faced in 2020's historic changes, and important milestones in developing a recommender system that's focused on inventory curation. This recommender system Style Explorer predicts what items their clients will love. Often, those items have then been fabricated. Providing Style Explorer as a tool available at all stages of Stitch Fix's vertical supply chain has de-risked and augmented processes ranging from design and fabrication to purchasing at Stitch Fix. In this process, it has transformed and scaled their visibility into what people like you and I love. Enjoy.
Stitch Fix's vision is to transform how folks find what they love. And today we'll look at one of the algorithmic components behind the scenes that helps Stitch Fix achieve that by scaling and transforming Stitch Fix's visibility into what people will love. We'll look at what we've got to work with, the recommender system that we built on top of that, of whether or not we should take a bet on a style and bring it into the ecosystem, the work that went into integrating that recommender system into the supply chain, and once you have something this powerful laying around, how you can take that one recommender system and use it in new and interesting ways. What do we have to work with? Well, we're working in an environment with just over 4 million active clients who are doing just under 2 billion in revenue with us. And from the client's perspective, they join Stitch Fix, they fill out a style profile where we start to get data points about what they like, what will work for them. We match them to a stylist who is supported by the algorithmic systems inside of Stitch Fix, who chooses 5 final items for going into a box and then is sent out to our clients if they're on the Fix engagement model. Once these items are in the client's home, they get the chance to try them on, match them with other things in their wardrobe, figure out if this is going to really work for them, and they provide us feedback on the fit, the quality, how these items resonated with them. Tapping into that supply chain just a little bit, we largely bring in items from 2 broad categories: market brands or third-party brands. These are items that you can get from multiple retailers, and also Stitch Fix exclusive brands, brands that work just with Stitch Fix. Once those items are brought into the ecosystem, they can go to our photo studios where we can start to photograph them, measure them, collect data points on the feel, the softness, the material of those items, and we can start to build up a data profile of what these styles are, match them with clients in our ecosystem, and get a very rapidly insightful feedback loop as clients respond to those styles. And once something's in our ecosystem, we're starting to collect that data and get that client feedback, we start to really hone in very quickly on how well it's going to do for different clients. The challenge, though, in a supply chain is, could we create something that would tell us how a style would do before we even brought it into our ecosystem, before we started collecting data on it? And for someone who, before I started working at Stitch Fix, most in-depth view of fashion was the devil wears Prada, that was a little bit of an intimidating prospect. But we did manage to build Style Explorer that, in fact, did have enough power of the data to help inform what we bring into the Stitch Fix ecosystem. So here's the architecture. When you're working in a challenging space and you've got a tough problem ahead of you, don't make it more complex than it needs to be. And so one of the mantras that we used for designing this recommender system for what we bring into the ecosystem was design for millions, not billions. Keep it simple where it could be, and focus in on the subtleties that would make a difference in this ecosystem. So we've got our inference architecture, our training architecture, and how they all come together. Now, why did this work? Why did this work? It comes down to two key competitive advantages. One is style shuffle, that we could actually take an image of an item, show it to our clients through the Style Shuffle game, which is available on our desktop and our app, and a way in which we collect feedback from clients on what styles resonate with them. We could take items that we hadn't officially brought into our ecosystem, show it through Style Shuffle, and get early feedback from clients on whether or not that style was going to resonate with them. Now, keep in mind, we like things that we don't necessarily wear. And so you have to take that style resonance, couple it with the intrinsic characteristics to ultimately predict garment performance. One of the curveballs we threw at this system is we're ultimately bringing in styles we haven't seen before. So why would it work? Why should we be able to take a style that we haven't seen before? Obviously, we get the Style Shuffle data, but why does that work? And one of the curveballs we threw at this system was the leather bodysuit. I had to look up what a leather bodysuit was. It's a top that is worn by women. What it breaks down to is, even though leather bodysuits are not that common, they break down into characteristics of fashions that we've seen before. We've seen black bodysuits before in several different silhouettes, and we've seen how leather impacts how folks respond to different garments. So the combination of which gives us enough power in the data to build a recommender system. So here's a sample of the output. We take minimal input of a picture of the item, a little bit of metadata of what it's made out of, the price point, the brand, the vendor, things you can't get from the image. And we provide a detailed product market fit of where this is going to resonate in different parts of our market. When we were designing the system, one of the critical decision points we had to make is that the world of fashion is quite varied, where some items you'll get in a spreadsheet with just an image and a little bit of metadata, and other items you'll actually get the whole blueprint where you even know what type of stitch they're using on different seams, which impacts the flexibility and stretch of a garment and the fit. And one of the critical decisions that we made was actually to assume the minimum amount of data on each style that we were considering bringing into the ecosystem. And the reason that was critical was twofold. One is that it allowed us to consider the greatest set of candidate merch on a fairly equal footing in this recommender system, and it simplified the design. But at the end of the day, fashion is a very large space, and the more that you can consider in that space, the more you're opening up your candidate set for what you can bring into the ecosystem. The other component of this is that fashion is still a very hybrid environment where a lot of information is passed around in emails with spreadsheets. There are some APIs, but at the end of the day, by keeping the amount of data required for can I consider this new style to be very minimal, it also made it easier for the folks going out and getting information about what styles we could consider. And the easier you make it on buyers to go find what's out there in the marketplace, the easier it is for them to upload larger and larger candidate sets of what styles we should be bringing into the ecosystem. The second was to parameterize business context. And this seems intuitive at the end of the day, but it was a tricky decision at the time of how do you parameterize your business context? And you want to break it down to You want to have enough parameterization in the business context to know, why am I bringing this into the ecosystem? Am I bringing it in for the UK market, the US market, the men's, the women's, the petites, the plus? You have to break it down. And the other aspect of parameterizing your business context is, as Stitch Fix has grown and developed more surface areas, more touch points with our clients, different fashions will perform differently in different touch points. So by parameterizing the business context, that gives you an ability to know, why are you bringing something into the system? The last one is that Stitch Fix is a growth business. And with that, the target metrics are changing over time. So we've developed a very flexible system that allows for multiple metrics and can be supported by multiple models behind the scenes, handling that complexity of different business contexts for different target metrics. Okay, so we brought in and parameterized business context metrics, and there were several other ones of, could we ask for more data here? Should we provide more flexibility to our buyers to know why they're bringing something into the ecosystem? But one of the critical design decisions for bringing a recommender system like this on in a high ROI manner is to borrow from engineering, both construction engineering and software engineering, of be very purposeful about the degrees of freedom that you set up in a system. You don't want to over-specify an axle. If you over-specify a system, then every part that you don't actually need dramatically increases the maintenance that you need for maintaining the health of that system. Okay, so how did we build it? We designed this before the spring of 2020, and we did have to adjust the ways of working. We had to set out a very nice plan, build, test, learn, release cycle, where we knew the architecture that we needed to go after. We knew that it was designed for the space that we were going after, and we were going to plan, build, test, and learn and release, given a space where we knew all of our unknowns. And then we got 2020. So how did we handle it? There's one project management technique I'd like to share, and that is the concept of steel thread versus modular development. Modular development is a common way to handle those recommender systems where you know what you need to build. You'll build each module out at a very good fidelity, and then you hook them all up at the end, possibly with some integration tests along the way. However, steel thread is the concept that you have your architecture, but you're going to put the bare minimum in place for each module. In some cases, we slapped a SQL query in a few of our modules. And the imagery that I have for working through steel thread versus modular development can actually come from a visualization and real analysis. If you're going to integrate over two dimensions, the architecture and the depth of development inside of each module, the difference between steel thread and modular development is actually just flipping the order in which you do things. So do you integrate dx dy or dy dx? Okay. So how do you do modular development? You mock out the endpoints, you allow teams to go deep inside of each module, and you've got a slow but sure path on bringing everything together. Steel thread is much faster, but you're releasing at a make it barely work product inside of each module. Now, how is steel thread different from minimum viable product or Boehm spiral development in software engineering is that with steel thread, you're still sticking to your full production architecture. You're still insisting that every single module needs to be there, versus in Boehm spiral, where you may skip over entire sections of your architecture and bring them in at a later date. The benefits of doing a steel thread is that it allows you to test that architecture and very quickly find make or break product market fit and architectural flaws much faster. Module development, on the other hand, is much better at parallel tracking teams. But in 2020, we found that steel thread was a much better form of development. Folks were in needed a sense of high focus at work, and steel thread very much enables a high focus because you're pulling off bite-sized, barely make it work module tasks one at a time. You're doing high touch points across the team with daily stand-ups, which enables folks to rotate in and out as they need to adjust for the broader environment. Make 2021 be a little bit easier on their development cycles. So we got this up and running with steel thread, and one of the growth points that we quickly identified with having this released was that we had set it up so that our buyers were having to specify that business context, that we were asking them to specify, I intend to use it in the UK for men's on this surface area. And what we found was that the cost of rerunning the model for all different combinations of those different business contexts was actually very low, but providing that full picture back to folks making a decision on whether or not this item, this style should come into the ecosystem, gave them a more comprehensive picture for, was it a style that would do well across multiple channels and a bit of a safer bet, or was it a style that it really needed to be specifically targeted in a very specific part of our market? Otherwise, it would be a high risk style. So having that full picture was something that helped them make their decisions. So growth point number one was that we actually went ahead and changed the UI to automatically run those different business context target metric combinations so that folks making decisions could just go ahead and get the full picture of how this would do, not just for their primary purpose, but in their secondary purposes as well. Another growth point once we got this up and running was to understand that fashion, the predictability of fashion, is there is a component of fashion that is deterministic. Folks do have price points, they do have fits, they do have responses to different materials that are very deterministic. You can have 5 different styles that have those things in common and know how folks are going to react to that. However, the error, as we started to tune the system, started to form into 2 different types of influence. Is that we had probabilistic influence of, we could measure probabilistically how someone would respond to a style, and then there was just chaotic influence. Chaotic influence is the difference between sending someone a style on a Wednesday versus Wednesday morning versus a Wednesday afternoon, 1 week versus the next, and there's no ability to really understand how folks are going to respond to that style due to just chaotic outside influence. And so we started to understand, as our metrics got more and more accurate, that there were unknown things that we could make measurable, and we could bring in, we could add additional image processing techniques to get more measures on, and so we put those on the roadmap and continue to bring those in into the ecosystem and increase our metric accuracy. But at the end of the day, when it's probabilistic and unknown or just strictly chaotic, you have to use confidence bounds. At some point, there's some part of fashion you can't predict. And you have to have confidence bounds of knowing, is that going to influence the performance of the style a little bit, or is that going to influence the style, the performance of a style quite a bit? And so by adding confidence bounds and multiple metrics around the stability of our predictions, that gives you a more full picture of how well we can predict the style. Okay, so we built this amazing recommender system, but it's not just enough to know what's going to happen in the future. You have to be able to make that actionable. And this is where we hired in our first ML integration data scientist. And this was just an absolute critical hire. And I'd like to share some of the work that they did for really helping this recommender system land and be used in production. We've seen the studies that show that a large number of ML initiatives and AI initiatives don't actually make it into production. And by having someone focus on not just building the ML, but focus on that integration between ML and business processes, where they could understand the business context, understand what really needs to happen on the change management for this recommender system to be used, was a very powerful feedback loop that really helped us land this. So if you want to bring in an ML integration person, the inspiration is on the left. We wanted someone that was good at team dynamics, machine learning, data science, and understood large businesses. We found someone who had done data-driven breweries, data-driven education, and had a very solid background in ML. And we were very, very blown away by the impact that they've been able to have. One of the areas that they took on early on was you have this prediction of how items are going to do, but how you act on it is actually a policy. Do you drop the riskiest 20%? Do you drop the riskiest 10%? Do you double down and buy deeper into areas that are going to do well? And so they helped set up simulations where we could simulate policies of how we rolled this recommender system out to buyers, and used it to help inform what their ultimate buys were for bringing things into the ecosystem. And that really also helped define the business value associated with this recommender system. They also helped with traversing the Uncanny Valley of ML. So quick aside, what is the Uncanny Valley of ML? This is from previous work that looked at when you have a person that's making a decision of yes, no, and you bring in an ML or AI system that's making a recommendation of yes, no, what happens as the accuracy of that ML system changes? I think we're going to see an increasing number of cases where we are going from human decision systems to systems with ML in it. And I think that's a combination of factors of MLs getting cheaper and easier with human decision systems are expensive to maintain, and we're getting fewer experts in the critical, quote unquote, older fields that have the self-contained knowledge to be able to make these decisions very well. Okay, so the ideal concept is that we can just add ML to the system, and that as the ML increases in accuracy, because we have that unbroken backbone of the human making the final call at the end of the day, we should only ever see improvements in the system. That if the machine is making poor recommendations, the person can just ignore it, so we won't see any degraded system performance. So we'll maintain at least the human accuracy of the system, and as ML accuracy increases, they'll become more reliant on the ML, so the time will go down and the accuracy will become the ceiling of what the ML can do. Okay, unfortunately, the Uncanny Valley of ML is when ML accuracy is roughly the same as the person's accuracy, you actually have a conflict that happens. And that Uncanny Valley is right at that crossing point where when they're roughly the same accuracy, you actually see overall system degradation where the two systems fight each other. You see an increase in time and cost per decision, and you also see the accuracy go down. We're making business decisions here with money behind them. We do not want to see the accuracy of which items we should be bringing into the Stitch Fix ecosystem go down. So how do you step across it? And that's where this ML integration person really helped us step across that. This is a tough thing to measure. How do you find when you've passed the ML Uncanny Valley of ML. I would love to see more academic research in this. In the meantime, what we found was we could measure the accuracy of buyers making decisions, of things being brought into the ecosystem, and we could measure perfect performance, time travel, and say that if we had known exactly how different styles were going to perform before we purchased them, what the optimal performance was that we could have expected. And so what we found was that if we split the difference between those two, if we got halfway across those, that we'd actually stepped over the uncanny value. And at that point, then it was safe to roll that recommender system out into the different parts of the business, making decisions in those different areas. So if you want to implement this metric, find your crystal ball lift, find your baseline performance, and make sure that the ML that you're introducing into the system closes at least half that gap, and then that can help inform your rollout plan. Okay, so we built this powerful system. If you have such a powerful system, it's hard not to want to reuse it. And I think this is an idea that I want to see developed more in the data science community. As we start to think about the environmental impact of our models, these models require a lot of energy to keep retraining, keep running. If we've put all that energy and investment into these models existing, can we find higher ROI ways to use them, and use them in multiple contexts? Once you get past the training stage, the inference stage is quite cheap. So you get a very good, if you can reuse your core model in additional decision points, you'll get a much better impact for how much energy you spend on these models versus the ultimate business impact that they can have downstream. And at the end of the day, for this ecosystem, we want to be avoiding waste in bringing in styles that are not going to be sold. So let's see how we reuse this recommender system in multiple ways. And this is where we get to growth point number 3. The first context that we released this in was for buyers deciding should a single garment or single style come into the ecosystem or not. And buyers working in those different business contexts knew the space like the back of their hand. They knew what the expected performance was. When they saw a predicted performance well over that, they knew that was a winner. And performance does vary quite wildly across different business contexts. And as we opened this up to more folks, we realized that folks didn't quite know what that baseline was. What's that high watermark? When do they know when they're seeing something good? And so that's where context matters, is that if you can provide the context for, I'm predicting that the performance of this style in this business context will be X. And by the way, that's the best we've ever seen. That helps inform different types of decision making. And so the different horizons that this tool is actually used to help make decisions on is the base one that it was built for of should I buy this garment or style? Now, if you can run this for one style, you can run this for 50, you can run this for 100. And then when you can upload 50 to 100, then you can look at, should I onboard this vendor? Does this vendor have a catalog where significant parts of this catalog are going to resonate with our market? And so from providing an aggregate view of, well, a vendor with an average performance of X in the target metric Y is actually one of the top vendors that we would see in that space, and we should engage with them, helps the strategic decision-making of should we onboard this vendor. Now, we'll call out, this has to be a hybrid environment for bringing on this vendor. There's quite a few elements that go into quality vendors that you could spend a decade trying to get into ML, where a quick phone call would tell you, is this supply chain going to be stable? Is this supply chain going to be responsible? And is this a supply chain we want to support? So then bringing this up one more level is that if you can put 50 to 100 items through it, you can put a couple hundred through and figure out, will this trend land for our clients? So testing, for example, cheetah print, let's upload 100 items of cheetah print and see which parts of our client base will resonate with that trend, and how will that trend land for our client base. Even though you may know that animal print is going to be the next trend, the various incarnations of that trend are without data and that client feedback are very hard to tell how it's going to land. Going up one level beyond that is to help figure out the aesthetic level of how is modern, how is heritage, how are different aesthetics going to land for our current client base, and how should we fold that into our buying strategy. And then the last is that because we can tune this into different parts of our client base, is that we can take a look at, as we get growing parts of our client base, hone in on, for those small but emerging parts of our client base, what aesthetics will our future clients want. The last bit, and I'd encourage folks that work with these big complex systems to think about a takeaway here. And that is reusing models to benefit the broader ecosystem. So last summer, Stitch Fix launched the Elevate program specifically for supporting Black and Indigenous people of color that were emerging in the design space. And we supported them with a cash grant, and we also supported them with giving them access to this recommender system. And this recommender system gave them early product market fit for how different parts of their portfolio were landing with different types of client base. And they were able to use this to look at optimizing their digital presence, optimizing how their portfolios were presented to other retailers, and getting insights of, as they're going through that growth curve, what parts of their portfolio were going to resonate with a larger audience. So these were some incredible folks to work with, and I'm absolutely just warmed in my heart that we were able to take a powerful recommender system and reuse it in a meaningful way to help others. And I will call out that working with them was also a two-way learning street, where they helped us as well on learning what it meant to help others. And that's one last parting thought I'd like to leave is from Wade Davis. If you get the chance to see him speak, he's an NFL player that works with Netflix on figuring out what we should be doing going forward. And one of the tough thoughts that he left me with was that we can contribute to the world today, but tomorrow the slate is wiped clean. And the first time I heard that, it punched me in the gut, because I was like, I did so much good work today. But if we come in with the fresh attitude and not resting on our laurels each day as we go into the summer of 2021, and bring in that energy that we brought to the table over the course of our last victories, and keep going, that's where we can really start to ratchet up these systems and really find great ROI for the incredible models that we've built, being able to use them in a broader context for helping the world out. So thanks very much. And this is work that was led by the style discovery team at Stitch Fix, and it's an intense amount of collaboration across the company. Thanks very much.
That was June Andrews, former head of data science at Stitch Fix, sharing the lessons and challenges faced at Stitch Fix in 2020, as well as important milestones in developing a recommender system focused on inventory curation. If you'd like to watch more videos like this, you can subscribe to the DSS Insider program, where you can see our complete on-demand video repository from a wide range of topics. Subscribe the links in the comments, and also make sure to follow us. Thank you.